let's talk big picture first. So looking at the syllabus for the calendar, sine, cosine, and tangent graphs. Tomorrow, or no, that was yesterday. Today, transformations with graphs. Block day, graph practice. Friday, it's basically more graph practice. Tuesday, graph practice, then review. So after tomorrow-ish, we'll have seen everything. It's just practice, 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 because there's a lot to cover. And so today we cover a piece of it, but I want to cover all of it briefly, and then we'll dive in and look at the details. Maybe this will make more sense in a minute. So on that notes page that I gave you, so we're going to ignore the first page and a half or so and go to the, you know what, let's make it easy. Just flip to the back. There's a blank page. Just all the way at the back. This will be the easiest way to do it. Let's briefly cover all of the transformations. And you'll be swamped. You'll be like, I don't understand any of those. I'm like, that's fine, I know. But before we dive in individually, let's take big picture, and then we'll go in piece by piece, and then later we'll sort of zoom out again and see if we have an understanding. So I really don't expect you to understand everything we're about to go over yet, anyway. But this is the survey. This is the 30,000 foot view of the land. After we do this, we'll land the plane and we'll go investigate A, C, and D today, basically, and we'll look at B tomorrow. Because you can't. There's just too much going on to investigate it all at once. So big picture, that's what our trig functions will look like, and it could be sine or cosine. Or tangent, for that matter. But mostly it's sine and cosine that we deal with. So again, we're going to briefly go through A, B, C, D, talk about what each of them means just briefly, and then we'll go in depth on some of them today and some of them tomorrow. A, the number out front, the multiplier out front. Any guesses on what that does based on your prior knowledge of parent functions and transformations? And
stretches and compress.
It's a stretch and compress. Now, with wave functions, it has a special name. We used it once or twice yesterday. The name for what controls how tall it is above the midline, above and below the midline? Amplitude. Amplitude. And so that's exactly right, though. It's a vertical stretch if it's bigger than 1, compress if it's less than 1. Oh, it could also, what happens if A is negative?
Flips.
It flips. So maybe a flip. The good news is you guys are so good at parent function transformations. Like, you apply that knowledge to these graphs and you'll be okay. There's a couple of differences, but for the most part, like, you already got the idea that A controls like the vertical stretch. You're absolutely right. What you don't know yet is what B does. B controls the period. So careful how I worded that. B is not the period. B controls the period. What's the normal period for sine and cosine? 2 pi. The normal period is 2 pi. Well, the adjusted period, or the new period, is 2 pi over B. So if B is 1, then the period's 2 pi. But if B isn't 1, then the period's not 2 pi. And a bigger B means a smaller period. And small b means a larger period. Another way to say this is it's a horizontal stretch or compression. So it stretches the wave out or squishes it up, left and right. And again, it's a little bit backwards, so the bigger B is, it actually squishes it up. If B is small, it stretches it out. All right, the next two I think you know. Like what is, so forget all the rest of that stuff. If there's something in parentheses with X, what does that do to the graph? A horizontal shift. And in wave world, we have a specific name for that. It's called a phase shift. But yes, it's a horizontal shift. And it works just like it always works. So if X plus 5 is in there, which way does that move the graph? Left. Good. And X minus 5 moves it to the right 5. And then lastly, D, what does that do? What does that normally do? A value there at the end. A vertical, not stretch, but a vertical transformation, vertical shift. Vertical shift. So that, one way we can think of it is it moves the midline up or down. So it's still going to be oscillating, but we shift the whole thing up or down. Now that's the concept of what each variable does. But now how to graph them, how to use those letters. And this kind of works out well. You use them in reverse order. When you're graphing them, you use them DCBA. If you don't use them in that order, you're going to get messed up. I mean, it can be done, but it's just a whole lot easier if you'll use them in that order. DCBA. So D, you would use the vertical shift. To move the midline up or down. So do that first. And then with C, use the phase shift. To go left or right. To locate what we call the new origin, kind of the new starting point. Because we're not going to start at the origin if we've got a shift left, right, or up, down. So the combination of C and D will help us locate a new origin. To use B, we'll go one period away from the new origin. And that would be the end of the cycle. That would be where we start over. Again, maybe this doesn't really make sense yet because we haven't done one. But we're trying to get the overview and then we'll dive in. And then you'll use amplitude for wave height. And then the points I want to see are the ones we've been graphing, the zeros, the mins, and the maxes for 2 cycles. It's high. Back up this way? Oh, just because my face was in the way?
Is that 2 cycles or Z cycles?
2 cycles.
Sure.
Where Z
Well,
equals
all these
2.
are letters, so, you know.
All right, so that, like, if you understood everything I just said, you'd be fine for the test. But that's a long way away. So let's flip it over and look a little more in depth at Notes 2, translation of trig graphs, amplitude. Reflection sort of goes with amplitude. That's A. Horizontal and vertical shift. So horizontal, that was left and right, so that's C. And vertical shifts is D. Changing the period is the hardest part, so we kind of saved that for tomorrow. It's hard to get everything in one class period. So we'll do the deep dive on A, C, and D today. We'll do the deep dive on B tomorrow, and then the rest of the time is just sort of putting it all together. All right, we know what the graph of sine of X looks like. You can't really see the x-axis labels, but let's label it ourselves. Let's say that's not an accident. What is this point that I'm pointing at? What's the x value right there? How did you know that was 2 pi?
Because the way it starts.
Because the period is 2 pi. It starts over at 2 pi. And so that was an accident that you couldn't see those, but it kind of works out well and is a good reminder for us. So the graph of 2 sine x, on the same scale, everything's been stretched up. So the amplitude is 2. Like the height above the center line or the height below the center line, you could measure it either place. Usually we think of it as above, but you could measure it either way. The amplitude is 2. We usually avoid saying the height of the wave because it's like, well, do you mean from the center line or do you mean the total height? That's why we don't ever say height of the wave. We just say amplitude of the wave. Starred. The sine or cosine coefficient affects the amplitude of the graph. So the A in front affects the amplitude. Amplitude is never negative, so even if there's a negative 3 there, the negative flips it over, but we still say the amplitude is 3. Here's an example of negative 2 sine x. Can you see how this graph is flipped from the original? Like the original would look like this. Oops, that would be 2 sine x. The black one has been flipped over, negative 2 sine x. So it's been flipped. So a negative out front causes a flip. Like you already know that. So a lot of what we do today, you kind of already know. You just haven't used it with trig before. As with your other parent functions, we can shift the graph right, left, up, or down. This is what we talked about earlier. You know what? Forget the H and K. Let's go C and D. I like C and D better because then it's, to me, you find A, B, C, D, and then you use them D, C, B, A, and then you're good. And I'm not even going to say all this. We talked about this already. If it's in there with X, it moves it in X, and it's backwards. If it's not in there with X, it moves it up and down. Plus 5 is up 5, minus 5 is down 5. Let's get to some examples here. In fact, what I will do on just about every problem is write down A, B, C, D. So I'll find all of those things and then I will use them in reverse order. So for number 1, what's the amplitude? 3. What's B equal to? In some ways this one's easy, in some ways it's hard because the stuff's not there. What's the multiplier right there? 1. So be careful. So B is 1. What does that mean the period is? 2 pi over 1, which is 2 pi. How about C, the left and right shift? Like, what is it if it's nothing there? 0. And how about the up and down shift? 0. So I'm going to up and down 0, left and right 0. This one's a little bit weird. I usually put a little plus or a little cross at my new origin. This one hasn't gone anywhere, so I don't really have to worry about it. My period is 2 pi. So I know I'll have to fit the sine wave, the sine wave in between 0 and 2 pi. Sometimes, not always, but like with all the other graphing, sometimes I'll do a quick sketch of the parent function so that I know that after I mess with it, it still needs to look like this. Right? If I do all this stuff and I end up with a tangent graph, then I'm obviously way wrong. So I need to, sine starts at a 0, which means it ends at a 0. Halfway in between it's at a 0. Halfway in between there, halfway in between these first two zeros, is it a max, a min, or another 0? A max, like I'm looking at my picture here. And where is my max going to be for this particular problem?
3.
At 3. And then halfway between pi and 2 pi should be a min. And how far down is the min going to go? 3, because the amplitude is 3. I stretched it by 3. And it does say graph it between negative 2 pi and 2 pi. So I just need to mentally and then actually physically copy that backwards one. And then the nice and smooth graph. That's pretty good. Pretty good for my first sine wave of the day. Number 2, y equals negative 3 cosine cosine. So before I forget, I'm going to draw a quick graph of cosine. Like I know what cosine looks like, so I'm going to change it up, but it's still better to look something like that because that's what a cosine looks like. All right, how about A? What's A equal to? Negative 3. Be careful, that means the amplitude is 3 because the amplitude is never negative. So if you say A is negative 3, that's correct, but the amplitude is 3, so be very careful there. B is 1, which means the period is still 2 pi. C is 0, D is 0. So there hasn't been any left, right, or period changes. We're just, well, hold on, let's go in order here. D and C are both 0, so my starting point is still the origin. The period is 2 pi, so 2 pi away, I know I'm starting over. I should be careful, I shouldn't put a point there, because cosine doesn't start at 0. Cosine starts, where does cosine start? Usually 1 or a max. Where's this one going to start? 3 up or 3 down? What's this negative doing? Making it flip. So I'm not going to start at a max, I'm going to start at a min because of the flip. And then that means I'm going to end at a min.
There you go.
And then, so I get my starting and ending points, and then I kind of fill in after that. Halfway in between, what should be going on?
You should probably have it one
Yeah, well, normally halfway is a min, but it's been flipped, so halfway is a max. Halfway in between there are the zeros. So I stretched it and flipped it. And again, graph between negative 2 pi and 2 pi. So let's back up and do the same thing. Let's see if we can get 3 and 5 done. So number 3. What's A? What's the amplitude?
It's -2. No, amplitude is moving.
Well, yeah, be careful. That's two separate questions. A is -2. Its amplitude is 2.
Is it going to be absolute value of that, and it always makes it positive?
Yes. So the negative means it's flipped, but since I almost forgot it last time, I'm going to write it there, so I won't forget this time.
So the A is where you start, and it's just the positive version of whatever it is, no matter what is the amplitude.
Yes.
Okay.
B is 1, which means the period is 2 pi. We're not messing with the period today because that's the hardest thing to change. What about C? And instead of telling me what C is, tell me what it does. Which way am I moving? Right. How many am I moving right? I'm going to go right, pi over 2. And then what about that plus 1 at the end? What's that do?
Up 1.
Up 1. So now I'm going to use these in reverse. I've got more stuff going on this one. So I'm going to use the up 1 first. And I know that controls the midline, so I'm going to just go ahead and draw the midline on there at up 1. That's not really part of my graph, but that helps center my graph. And then I'm going to go right pi over 2.
And then that's your origins.
That's sort of my new origin. I like to put a little plus there because that's sort of my new starting spot.
Okay, then down to from there.
Let's see. There's what sine usually looks like. So we've done up 1, we've done right pi over 2. Period is 2 pi. So be careful. That doesn't mean I end at 2 pi. It means I end 2 pi away from where I started. So in theory, we don't have enough room on the graph. I'm going to go ahead and make room on the graph to get there. This will be where I start over. You can put another origin there if you want, because it's going to be the same graph. So that's a big deal. It doesn't end at 2 pi. It ends 2 pi away from where it begins. So sine usually starts and ends at 0. In the middle is a 0. Normally we would go have a maximum right here. But what's going on this graph? It's got to have a minimum. Now, and it will be at -1 because I'm going to go down 2 from the midline. So don't go down to -2. I'm going down 2. And then on the other side, up 2. Because amplitude is measured from...
Oh, okay. So you have to go straight down.
So there's one graph, or one cycle of the graph. And let's just extend it back. So every marker is worth, well, I'm just going to go all the way back 2 pi away because there'll be my. That's probably the easiest way to go. Whoop, got in a little hurry there. That's not the best looking sine wave right there. ABCD, DCBA. Pardon? Let's do number 5. That's when you get to a tangent one. Let's see. Oh, tangent's the tricky one. Let's back up a second and think. Most people don't like tangents, but there's what it looks like. So there's my super small parent function reminding myself what tangent normally looks like. Alright, let's still do the ABCD. Tangent, we usually don't have a multiplier on it because it doesn't have an amplitude. So this, we usually don't stretch them because it's hard to notice a stretch anyway. So you can say A equals 1 and be correct, but it doesn't have an amplitude. So again, A and amplitude aren't exactly the same thing. B is 1. So its period is unchanged. What is its period? For tangent, period is pi. And then plus pi over 2 means we're going left pi over 2. And minus 1 means you're going down 1. So we find A, B, C, D. We use them in the reverse order. So down 1, I'm going to, again, sketch the down 1 line because that's the middle of the graph. It's not a wave anymore, but it's still the midline of the graph. Left pi over 2 means my new origin is right there. Pi away from that, I will start the graph over. So if I'm at negative pi over 2, and I go pi away from that, I'm at positive pi over 2, so I could put another little plus sign there if I wanted to. And I may as well keep on going since I'm already thinking about it. So every pi, it kind of starts over. Not kind of, it does start over. Now, what's going on at the origin? Is that an asymptote or a 0 for tangent? Look at my picture. It's a 0. So all those new origins are zeros. And what's going on in between the zeros?
Each half step from that is a asymptote.
Yeah, in between the zeros are asymptotes. And then that's kind of all the points we have. We know what the shape looks like though, so we sketch in the A, B, C, D, D, C, B, A every time. Now, what's a little bit weird, maybe, flip to number 7. I usually don't. I guess officially you should to indicate that it goes on forever. But when you do that, where'd my arrow go? There it is. Then are you thinking, well, it goes down forever? No. So if you put them on, it's fine. If you don't put them on, that's fine too. Like, yeah, but if you do like a hooked arrow, then it looks like you turned your graph too soon. So there's no good answer.
Well, I mean, you can put like the half arrow on the
All right, number 7. We got 5 minutes left. We'll do number 7, and then we'll be done. State 4 equations for the graph below. Yeah, so wait a minute. Let me ask it this way. Is that a sine graph or a cosine graph?
It's a flip.
It depends on where you think it starts. I would agree that it's a cosine because it's starting at a max. So let's write one as a cosine graph.
Wait, just let's take 4 equations.
So y equals. I can definitely draw the midline, regardless of whether it's sine or cosine. I should probably be thinking about DCBA again here, or ABCD. Amplitude is 2. Well, yeah, amplitude's 2. Cosine. What's the period? How far is it from peak to peak? 2 pi. So that's good. That means we don't have to change what b is. And then what's my left-right shift if this is a cosine? None. And what's my up-down shift?
It's 1.
Yeah, down 1. So probably the easiest graph equation you could write is 2 cosine x minus 1. But you could get creative. What if instead you said, you know what, I think it starts over here. I think that's my starting point. So it's still a cosine graph. But what has the shift been if we're starting right there? How do I make it start right there? What would make it move to the left 2 pi? Plus 2 pi. And that amplitude, or that shift is always going to be minus 1.
Shoot.
I could do a cosine. What if I say it starts right here? A sine. If it starts right here, that's a sine graph. Amplitude is still 2. What's the shift been?
Plus pi over 2.
Yep.
And then, yeah.
There are an infinite number of ways to describe that graph.
So if I put infinity, it's not wrong.
If you just write infinity, that would be wrong. All right, you already have the worksheet for today. It's just more practice graphing. Tomorrow's block day, so we'll have some time to answer lots of questions and go over stuff. So do try it. Don't get behind and just say, well, I'll just figure it out later. No, try these, because tomorrow we're adding period, and that's going to mess things up a little bit. So try the homework tonight, and we'll go over some tomorrow.